YouTube, this is UMOS03. In the previous lesson, we basically took a look at two things. We looked at some techniques for two-dimensional arrays, right? For matrices, for essentially working with a two-dimensional array of ints or doubles, especially with 2 by 2 matrices, right? If you had 2 rows and 2 columns, then you can easily compute something called a determinant. And then we also talked about a vector, right? It's another type of data structure which is awfully similar to an array list. And we can go ahead and review some of those concepts in this video. But what we're going to do is go to the main method of our example class. We're in a class called example right now. And we're going to declare and initialize 4 ints on the same line. So we're going to say int v1 equals 4, v2 equals 16, v3 equals 1, v4 equals 4. And then we're going to create a two-dimensional array with 2 one-dimensional arrays in it. And the first one-dimensional array is going to have v1 and v3, so that would be 4 and 1. And the second one-dimensional array is going to have v2 and v4, so that would be 16 and 4. And then we're going to say v5 equals transpose of v5. So basically the transpose method is a method that accepts a two-dimensional array of ints and returns a two-dimensional array of ints. And we said basically that the transpose of a matrix basically flips the rows and columns. So if you have particular rows, well, now they're going to line up as columns, right? Every time you read from left to right, well, now those are going to show up basically as vertical columns rather than horizontal rows that are stacked on top of each other, right? Rather now they would be essentially columns that are stacked basically vertically from left to right. So hopefully that's clear to you and vice versa, right? But this would basically go ahead and say int result equals new int of array of 0.length, array.length, int b. For int a equals 0, a is less than result.length, a plus equals 1. B equals 0, while B is less than result of 0.length, result of AB equals array of BA. So this is the swapping operation. And you're basically, if you have an element at a particular row and column in your array, it's going to go into the column and row. You're going to flip the row and column entries in the transpose, and then you would just return the resultant two-dimensional array. So hopefully that's clear to you. But we would go ahead and just do the transpose of V5. So now instead of having V1 and V3 and then V2 and V4, we would have V1 and V2 and then V3 and V4 in the second one-dimensional array, because it's going to swap the positions of V3 and V2. So now we're going to have 4, 16 and 1, 4. And then we also talked about this determinant method, right? And we say example.determinant of V5. And so we're printing it. So it seems like the determinant method has to return something, and indeed it returns an int. And so for a two-dimensional array, the determinant is defined by the top left element times the bottom right element minus the top right element times the bottom left element. So it's going to be array of 0, 0 times array of 1, 1 minus array of 0, 1 times array of 1, 0, right? And then another way that you could classify a determinant method is to pass in 4 ints, right? So you could go ahead and pass in A, B, C, and D, and then you could just go ahead and create a two-dimensional array, right, where the two-dimensional array has those 4 ints inserted into it, and then you would just return determinant of that two-dimensional array on which those 4 ints that you passed into this determinant method are based. So hopefully that's clear to you. But we could go ahead and figure out whether or not those two versions of the determinant method, these are like overloaded versions of the determinant method, would return the same thing, right? So if we go ahead and print the determinant, we get 0, because 4 times 4 minus 16 times 1 is 16 minus 16, which is 0. And indeed, these two versions of the determinant method, the overloaded determinant method, would return the same thing. And so that's why we go ahead and print true here. And then if we say print sum of V5 and V5, so that would just add V5 to itself. And we said that would happen like entry-wise, right? So it's like the third row in the first column of the first matrix would be added to the third row in the first column of the second matrix, right? So what's 4 plus 4? It's 8. What's 16 plus 16? It's 32, right? What's 1 plus 1? It's 2. What's 4 plus 4? It's 8. So hopefully that's clear to you. And then we could also say second array in V5 after transposing. So that would be the 1 and 4 that we were seeing, right? After you flip the positions of V2 and V3, you would have 1 and 4 in the second array. And then we would ask if the two one-dimensional arrays within the two-dimensional array are equal to one another, calling system.out.println of arrays.equals of V5 of 0, V5 of 1, and that will be false. But then if we go ahead and reassign V5 of 1 to be arrays.copy of V5 of 0 with the same length as V5 of 0, then we would say system.out.println of arrays.equals of V5 of 0 and V5 of 1, and then that would return true. So hopefully that's a quick but helpful review of some more techniques for two-dimensional arrays, right? We talked about transpose, adding, subtracting, and determinant. We can also go ahead and think a little bit more about instance of. So now I'm going to go back to the vector function. And so we're going to create a vector of type object, right? So we said that a vector is a data structure that's just like an array list. And one of the things that you have to remember to do is import java.util.vector, right? Just like you have to import java.util.arraylist if you want to use array lists, or java.util.hashset if you want to use sets, right? But we said in a previous video that we can have a pretty general data structure. We can have a pretty general data type within our data structure. And the most general that we could have is called object. And like we've said in previous videos, object is the root of the class hierarchy, right? So every class is a subclass of object, right? And so we're going to say vector of type object things equals new vector of type object. And then we're going to add a string object, and then we're going to add a Boolean object, and then we're going to add an integer object, and then we're going to add a double object. That's what we do on these lines right here. And that's valid because all four of these classes are subclasses of object. If they're not direct subclasses, then they're subclasses of like classes, which are subclasses of object, but eventually they're going to fall down in the class hierarchy, right? So a Boolean is a type of object, right? We could consider a Boolean to be an object, but not necessarily the other way around, right? And then this would be adding a character object, and it goes ahead and adds those 5 elements to the same vector, to the same data structure. So this just gives you an example of how you declare, if you declare something as type object, then you have more flexibility in what data types you add to it. But you have to be careful because, like we said with polymorphism, if you're declaring object, you can't call like string methods on things.get of 0, right? Because this is just being rendered as an object right now rather than a string. So you would have to go ahead and explicitly convert it to a string. But how would you know whether or not it's a string? And that's where the instance of keyword is going to come in. So anyway, we're going to say, I think I'm just going to go ahead and run this right now. So we're just going to say vector function. Okay, and so there's a bunch of things printed on the console, but I want to show you what's going on here. So we're going to say example. So we're going to add summer. We're going to add not true, which is false, the Boolean false. We're going to add 105. We're going to add 1 over 2.0, which is a double, like 0.5. And then we're going to add this character, right? This symbol, the $sign. And then we're going to say example E equals new example. And then if you go to the constructor for this class that I made, basically the only thing that happens in the constructor, normally what we do in a constructor is we assign instance variables. But in this constructor, the only thing that happens when we create an instance of a class, when we create a new object, a new example object, is we're simply going to print new example to the console, right? And so that's what happens here at the beginning, right? That's why you see new example printed on the console here on the left. So hopefully that's clear to you. But then we could also say things.add of E. And so that's basically just going to go ahead and add an example to the vector of objects, right? Because example is a subclass of objects, even though we didn't write extends object. Every class is inherently a subclass of objects. And then we could say things.add of e.f, right? And so there's also an instance method called f, and it just returns an int, and it's called on an instance of an example, right? And so you would just say return 64. It just returns the number 64. So presumably that would be an integer, right? And then you could say things.add of 0 plus double of 0. So that would be like a 0.0. And then you could say object y equals new example. And that's why we print new example again, because we're creating a new instance of the example class. And now we cannot call f on y because y is declared as an object. That's a polymorphism thing that we talked about in a previous video. And then we could say things.add of y, right? And then we could say iterator of type object parse equals things.iterator, right? And then we could say for int q equals 0, objects parse.has next, q plus equals 1, system.out.print of element, you know, and then hashtag like the number, and then q plus 1. So we're going to want to index starting at 1. So like element number 1 is summer, because that's the first thing we added to the vector of objects, right? The second thing we added is false, because not true evaluates to false, right? And then we added 105, and then 0.5, and then the $sign. Well, what if we try to print the example object that we tried adding to the vector? Well, that just prints the hexadecimal representation of the hash code of the object. And that's why it's so important to have a toString method, right? You could also have a 64 here. And so that was just basically saying things.add of e.f. So that's why we were adding the 64 onto the vector. And then the 0.0, and then we also added y, which was another example, even though it was declared as an object, right? And then we can check the instances, right? And so we could say for each of the objects K and things, and then we could say if K is an instance of integer, we could say we got a number, add 20. And then we could say system.out.println of integer of K plus 20, because you would have to explicitly convert K from an object to an integer specifically if you want to add 20 to it. And so that's why we go ahead and say we got a number, add 20 to get 125, right? And so that would be, I guess, after these first two things. So we say instance checking, but what was the first thing added to the vector? It was summer, right? And so I guess if we scroll down, if we say if K is an instance of string, we say system.out.print of concat dot dot dot, and that's what shows up here. And then we're just going to say system.out.println of word.concat of word.concat of word, where word is the string conversion of the object K, right? As long as K is an instance of string, right? But it was declared as an object because you added it to a vector that was declared as holding objects, right? So that's why you have to explicitly convert it to the data type that you want to use the methods of, right? If you want to use methods from the string class, like concat, you have to do an explicit conversion. This is an example of polymorphism. What if it's a double? So if it's an instance of double and double of K is not 0, then we got a double. Multiply 2 by the reciprocal. So it's like the reciprocal will be 1 over K. But then if we say 2 over K, that will be 2 times whatever the reciprocal is, right? But that would only be valid as long as you're not dividing by 0. So you could say otherwise if K is an instance of double, right? And the only way this code would evaluate is if these two booleans did not evaluate, right? Is if neither of these booleans were true, right? So if K is an instance of double and double of K is equal to 0, we could say here comes a 0. And that's, I guess, what happens right here. Here comes a 0. And then we just say double of K dot int value, because remember, int value is one of the instance methods that belongs to the double class. So you call it on a particular double instance, right? And there's other examples here, but I think we're running out of time. But the point is that you can have instance checking, and you can print different things depending on what the instance of the class is, and you can do different things. You could get the character code of a character, right? But if it's coming in as an object, if you're adding basically an object to a vector of objects, then in order to check whether or not it's an instance of character and use methods from the character class, you need to say character object equals character of K. You need to do an explicit cast, and that's called polymorphism. So hopefully that's clear to you. What we're going to do now is we're going to talk about a couple more data types, a couple more primitive data types in Java, right? We've already talked about ints, doubles, char, boolean, and I think those are the 4, right? And so what we're going to do is we're going to learn about another one, okay? And so we're going to learn about a couple other ones. So in Java, an int is held by 32 bits or 4 bytes. And so what you have to think about is that in computer programming, when we create data, when we create like int x equals 4, that takes up memory in Java, right? That takes up space. And so an int is held by 32 bits. So bits are like zeros and ones. And so every time you create an int, it corresponds to a sequence of 32 zeros and ones. So maybe, 32,665,912 would be like, 11100001011011101. I'm not sure, but it would go on 32 bits, right? But a short is like an integer, but it is only held by 16 bits or 2 bytes. So it only takes up half as much memory. And the consequence of that is that it can only hold much smaller numbers, okay? So it cannot hold values anywhere near as positive or negative as you could hold with an int, okay? But a long is the opposite. So a long is like an int, but it can hold 64 bits, which is 8 bytes. That means that it can hold giant numbers that are much larger than integer.max value. So what is integer.max value? So if we go back to the integer class, we can remind ourselves that classes can not only have important and useful methods, but they can also have important and useful constants, right? So integer.max value is a constant that belongs to the integer class, and it's a constant that holds the maximum value an int can have, which will be 2 to the 31 minus 1. So if you multiply 2 by itself 31 times and subtract 1, that's the largest that an integer can be. But what we're saying here is that a long could be much larger than an int, right? And so which is a constant from the integer class that represents the largest int. But the point is that longs can be much larger than that, right? So if you go ahead and go to blackle.com, and then if you go to long Java API, what we're gonna do is we're going to go ahead and see long.max value, and that would be 2 to the 63 minus 1. And this is a much larger number, but the point is that longs take up more memory in Java because they're held by a longer sequence of bits. So it's just going to take up more memory. It's going to take up more space. But I want to go ahead and try out this method that I wrote here. So essentially, what we're going to do is we're going to do number function, and I want to show you the things that print to the console compared with what I wrote here. So we're going to say properties of an integer. And I just want to show you some of the different things here. So we say bits 32. So what is integer.size? So this is another important method that we could use here, right? So I'm just going to say long. So we're going to have another important. So if we say integer Java API, we're going to learn about another important constant. So integer.size is the number of bits that's used to represent an int. And so these other classes like short and long are also going to have size. And you can also figure out how many bits represent those different types of numbers, those different primitives. But we're going to say that integer.size is 32. So an int is held by 32 bits. Okay, the largest value of an integer is 2,147,483,647. And then there's also a class called short. And so you can hopefully after 60 lessons, you're comfortable Googling short Java API, and you can go ahead and study the methods and the constants that belong to the short class, the long class, the double class, and the float class. But assuming you're comfortable with that, we could say properties of a short, and you can see that shorts are held by only half as many bits. And that means that the number can only be much, much smaller, right? Only 32,767. But what about for a long? A long is held by 64 bits, and you can get a giant, giant number here. What about properties of a double, right? Remember, a double is like a floating point number, and that's held by 64 bits. So doubles actually take a lot of memory for the Java compiler, but they can get really large, right? You could have 1.797 times 10 to the 308, right? And then there's also something called a float. So a float is also sort of a floating point number, a decimal number, a number that's not an integer, but it's only held by 32 bits. And so that means that the largest float that you can get is only 3.40 times 10 to the 38, which is a tiny number. Just kidding, but it's a hell of a lot smaller than the maximum number that can be held by a double. So hopefully that's clear to you. What if we try to cast a giant long to an int, right? So we're going to say long a equals long.max value minus 4. So that'll be like 2 to the 63 minus 5. And then we're going to say almost the largest possible number for Java is this number right here. And so you can see all these digits. So that's like a giant, giant number, right? But then we're going to say casting this giant number to an int. And then we're going to say int of a, and we just get -5, which is clearly not correct. And you can see that there are problems with the way that Java tries to evaluate numbers, right? If you only allocate space for an int, it's going to have a hard time doing computations with a long, because longs require a lot more bits. They require a lot more space in order to perform computations with them. What if we try to cast a large int to a short, right? So almost the largest possible int for Java is like over 1 billion. But then if you cast this large number to a short, you get -1, right? The code for that is short of b, right? And so this is another primitive data type. That's why it shows up in red. Same thing with long, right? Long also shows up in red. These are primitives, but they also have wrapper classes with capital first letters, right? And then you could also say there's other conversions that you can do, right? And then you could also have an issue if you try to convert a float to a double, right? Because or actually, if you try to convert a double to a float, then that would be an issue, right? And so what if we try to cast a giant double to a float? There'll be a problem with that. This is the largest double. And then if you try to cast this large double to a float, you would only get about 1.07 times 10 to the 9. But the point is that there are different primitive data types in Java. And so we've been talking about int and double as numeric, but there's also long, short, and float. And so there's other things that you can do with these data type conversions. And we talked about how you can convert explicitly from a double back to an integer or from a string back to a double, right? Otherwise, it's going to implicitly be cast in the other direction. but there's a lot of different components that we've talked about in the Java programming curriculum. And so double and float are classes that you can go ahead and look up on your own, right? Hopefully you're comfortable going to Float Java API and learning about some of the helpful methods and fields that are provided if you do some research on your own in software engineering. From UMills03, thanks for watching and please subscribe.